Hello everyone, welcome to our next lesson. Today's objective will be graphing sine and cosine functions with vertical and horizontal translations. When a sine or cosine function has a vertical horizontal translation, the function will really be in this form: y is equal to a sine of b parentheses x minus h plus k, or y is equal to a times cosine of b times x minus h plus k. The a and b are the same from yesterday. Those are your vertical and horizontal strings and stretches. And the x minus h in the parentheses, this is your horizontal translation like always. And the plus k on the outside is your vertical translation. And recall that when you have a minus h, then you translate to the right. And when you have a plus h, you translate to the left. Just as a reminder, if you have a plus k at the end, you are translating your function up. And if you have a minus k at the end of your function, you are translating your function down. Oh, one more thing I forgot to mention is that when you have a horizontal translation of a periodic function, it's called a phase shift. Due to the translations, there's going to be a few extra steps for graphing cosine and sine. Firstly, we still want to identify the amplitude and the period, and now we will also want to identify the horizontal shift and the vertical shift. Next, you're going to draw a horizontal line at your k value, and this is called the midline of the graph. So you can think of the midline like how the x-axis was in our examples from yesterday without a vertical translation. Then you are going to find the 5 key points. So the key points were the minimum, the maximum, and where it intercepts with the midline in this case, but yesterday this was our x-intercepts. And then we will connect the points of the graph. So let's start off with graphing a vertical translation. We're going to start off by graphing g of x is equal to 3 sine of 2x plus 5. Let's first start off by identifying the amplitude. The amplitude here is 3. Now we want to find the period, and to find the period, you take the coefficient of your x term, and then you divide 2 pi by that number. So I get a period of pi, so we know that our function is going to complete one cycle in a horizontal length of pi. So I'm going to place pi on my graph and divide it into quarters, and I'm going to do the same on the negative side of the graph. Next, we are going to identify the horizontal and vertical shift. Now, because there is no h value here, so like over here, the h value would be in parentheses with your x, and since we don't have that here, there is no horizontal shift, so I'm just gonna say h is equal to 0, and we have a vertical shift of 5. You're going to draw the midline, and the midline occurs at y is equal to your k value. So I'm going to draw a horizontal line going through 5. There's our midline, y is equal to 5. And now I'm going to use the amplitude. And remember how I drew those lines yesterday? That gave me a guideline for where the minimum and maximum are, and how the function is going to bounce about from the minimum and maximum. So I'm going to do that. Because the amplitude is 3, I'm going to count up 3 units from the midline and down 3 units from the midline. So this means we have a maximum at 8, and we have a minimum at 5. Now that we have our graph set up, let's start graphing our function. Sine of our function starts at the origin, and because we have a vertical translation of 5, we actually have to shift up 5 from the origin to the point 0.05. Since the period of our function is pi, we know that the function will complete a cycle at pi. So when x is equal to pi, our y is also going to be equal to 5, because the beginning of the cycle and the end of the cycle have the same y value. Now we're going to use those quarter points and the amplitude lines to fill in the rest of the graph. So we know that after a quarter, we're going to reach our maximum. So here at pi over 4, we will reach our maximum at 8. And then our graph goes back down to the midline. And from the midline, it will go down to our minimum and then back up to our midline. And that pattern will also be the same on the negative side of the graph. So from our origin, we go down to the minimum, back to the midline, up to the maximum, back to the midline. And now let's connect the points of our graph. Don't forget to draw arrows at the ends. And here's the graph of our function. Let's do a vertical translation one more time. Down here for monitoring progress number 5, we are going to graph cosine x plus 4. And let's identify the amplitude and the period first. Amplitude here is just going to be equal to 1. The coefficient of the entire function is 1. And to find the period, we want to take 2 pi and divide it by the coefficient of x. And here, the coefficient of x is 1, so our period is 2 pi. So let's place 2 pi on our graph and always divide it into quarters. And now let's find the horizontal and vertical shift. Here there is no horizontal shift because we only have a cosine of x. If this function were cosine parentheses x plus 4, then we would have a horizontal shift. But because it ends like cosine x, this plus 4 is our vertical translation. So our k is equal to 4. Once you identify the vertical shift, you want to draw the midline, and the midline occurs at k. So I'm going to draw a horizontal line going through 4. And then we want to use our amplitude to identify the minimum and maximum. So you're just going to take your amplitude and add it and subtract it from your midline. So we are going to have a maximum at 5 and a minimum at 3. And apologies, I should have drawn my graph a little bit bigger. So if you're following along, you can make yours bigger. Since this is set up, let's start graphing our function. The y-intercept of cosine of x at 1. But because we have a vertical translation of 4, we have to shift it up 4. So our first point of this graph is going to be at 0, 5, our maximum. All right, and then our next point, we go down to our midline, because usually our cosine graph would go down to the x-axis. Then we go down to our minimum at pi, back up to our midline at 3 pi over 2, and then back up to our maximum 5 at 2 pi. And let's draw another cycle on the negative side of the function. So from our maximum on the y-axis, we want to go down to the midline at negative pi over 2. And then at negative pi, we go down to our minimum at 3. And at negative 3 pi over 2, we go back to our midline. And at negative 2 pi, we go back to our maximum at 5. Once you have those points mapped out, let's connect. And here's our graph of cosine x plus 4. Let's move on to graphing a horizontal translation now. Next, we are going to be graphing g of x is equal to 2 cosine of 1/4 times x minus pi. So this 1/4 times x minus pi is all inside the cosine. Let's first start off by identifying the amplitude and the period. Amplitude here is 2. And to find the period, we're going to take 2 pi and we are going to divide it by our b term 1/4. Now dividing by a fraction is like multiplying by its reciprocal. So our period is going to be 2 pi times 4, which is 8 pi. Now let's mark our 8 pi on our graph. 8 pi should be somewhere over there. And as always, we are going to divide that into quarters. Now let's identify the horizontal and the vertical shift. Now because we have a minus pi over here, we have a horizontal translation pi units to the right. And we do not have a vertical shift, so k is equal to 0. So our midline is going to be at the x-axis, just like the transformations that we were working on yesterday. Let's use the amplitude to identify the minimum and maximum. Since the amplitude is 2, we are going to have a maximum at 2 and a minimum at negative 2. Now what I'm going to do next, I'm just going to graph it using transformation. So I'm actually going to start off by graphing the function without the horizontal translation, and then we're going to shift it pi units to the right after. However, if you would prefer to do it algebraically, you could just take the normal cosine x values and you would just add pi to it. But I'm first going to start off by graphing the function without the horizontal shift. Cosine starts at the maximum on the y-axis, and then it goes down to the x-axis, down to the minimum, back up to the x-axis, and back up to the maximum. This pattern repeats on the negative side of the graph. So now that we have those points filled in, we just need to shift these points pi units to the right. Now because each of my tick marks represents a pi, we need to go halfway between each to shift our function to the right pi. So we are just going to shift each of these points pi units to the right. Now I just need to connect those points that we just got. And here is our graph of 2 times cosine of 1/4 times x minus pi. Let's do this one more time. And afterwards, we are going to combine both a horizontal translation and a vertical translation. Next, we're going to be graphing g of x is equal to 1/2 times x of x minus pi over 2. I've already identified the variables that we need to know. Amplitude is 1/2, period is 2 pi, and there is a horizontal translation pi over 2 units to the right. Because there's no vertical translation, our midline occurs at the x-axis, and because the amplitude is 1/2, we have a maximum at 1/2 and a minimum at -1/2. So this time I'm going to graph algebraically. So normally for your sine graph, you would start at the origin, but we are going to shift this point pi over 2 units to the right. So it will move from 0, 0 to pi over 2, 0. Next, we would normally have a point at our maximum. We need to shift it horizontally pi over 2 units to the right. So our maximum point will now occur when x is equal to pi. And then we can just continue the pattern. So it's going to go back down to the x-axis, down to the minimum at 2 pi, and then at 5 pi over 2, the function will come back to the x-axis. And let's just continue the pattern on the left-hand side of the graphs. And now we just need to connect our points. Let's move on to our last example, where we are going to be combining both vertical translation and horizontal translation. Next, we're going to graph sine of x plus pi minus 1. Amplitude of the function is 1, the period is 2 pi. There is a horizontal translation pi units to the left because we have a plus pi in parentheses, and we have a vertical translation down -1. Let's draw our midline at -1. And because our amplitude is 1, we are going to have a maximum at the x-axis, and our minimum will occur at -2. Since our function is sine, it usually starts at 0, 0. But because we have a vertical translation, this is going to get shifted down to our midline at -1. And because we have a horizontal translation pi units to the left, we must translate our point pi units to the left over to -pi. Our next point would normally occur at the maximum when x is equal to pi over 2. But again, because we have a horizontal translation, we're going to translate this point pi units to the left, so over here. And once we have those 2 points, we can just continue that pattern. So from our maximum, we go down to our midline, down to the minimum, and back up to our midline. And let's continue that on the negative side of our graph. And once we have those points, let's connect them. And there's the graph of our function, sine of x plus pi minus 1. That's it for our lesson for today. Please let me know if you have any questions and come to office hours if you are having trouble. I hope you have a wonderful day and take care.